What's a terrifying truth about space that most people don't realize? How incomprehensibly large the universe is. There are about 400 billion stars in our galaxy, with an average of slightly more than one planet per star. That means that within our galaxy, there are over 400 billion opportunities for life to have evolved. This isn't even counting all of the moons, comets, asteroids, etc. within our solar system, or even the idea that life could evolve twice on the same world. On top of that, we live in a pretty average-sized galaxy that is one of over 2 trillion galaxies estimated to be within the observable universe. Given that the cosmological principle essentially says that space is the same in all directions, that would mean an average of over 400 billion chances for life to appear 2 trillion times. There is life elsewhere in this universe, no matter how rare the existence of life is. Even if it's a 1 in a trillion chance, that's still more than 800 trillion chance of life appearing. The thing that gives me hope, though, for generations in the future, obviously, is that while the known universe keeps growing as technology and our understanding of physics progresses throughout history, so too does the distance humanity can travel. There was a time when the average person stayed in the town they were born in, never leaving until they passed away. Now I could hop on a plane and fly to the other side of the planet within a day or two. There could be a day eventually where humanity could figure out something like warp travel and really explore the universe beyond our own solar system. I hope it happens eventually anyway. Right, given the sheer number of possible planets, I'm sure one of them is just a giant 7-Eleven where a CEO runs screaming from an earthquake. Why not, right? And before I forget, because why not, other me's over on Rufus Stories doing what he does best, unpacking some crazy relationship stories. It's a good time, I promise. Links in the description if you're down. Alright, back to the stories. Story 2. The number of theories as to why, if intelligent life besides humanity exists, it hasn't contacted us on a large scale yet. To wit, some of them are: we lack the capacity for interstellar communication. Earth is essentially a space backwater, and humans are so relatively primitive that alien life has decided it's better to leave us alone, like a nature preserve. The same as above, but the aliens are afraid of our savagery relative to theirs. There is no intelligent life besides ours. We have been in contact, but we can't perceive these beings. Extraterrestrials are too distant to be contacted. Story 3. The universe is expanding, but not into anything. Space itself is stretching, and there's no edge, no center, or quote-unquote outside. It's not just vast, it's fundamentally beyond how our brains are wired to understand reality. Now this messes me up in both ways. Is there some kind of end to everything where literally nothing exists beyond a certain point? Like, what is that all about, and how can there just be nothing? Also, if there's no end and traveling an infinite distance leads to endless new galaxies and stuff, why and how does that occur? It also equally messes me up to think about how this all started. It makes utterly zero sense to me. The Big Bang is bonkers. I'm no physicist and not well read on it, but everything just sparked into existence is bizarre. If the answer is God, somehow, naturally, I wonder, where did they come from? Is it a God responsible for our galaxy and all other galaxies have their own intentional creators? I don't know. These thoughts and questions really get me existentially spiraling. Story 4. There is no before the Big Bang. The Big Bang was the moment dimension was created. Both distance and time are a product of universal expansion, not pre-existing states that the singularity was suspended in. This is very problematic. If there were no measures of space or time to do work in, then where did the catalyst to start the Big Bang come from? Even worse, if you try to answer this by saying the Big Bang was just one of a series of expansion events and an infinite string of them, you still have the problem of answering how a thing can exist without an initial first event. There is no first event in either of those suppositions, a universe from nothing or an infinitely existing universe, and yet logically some permutation or another of one of those answers must be true. Either it had a beginning or it didn't. Both answers are equally preposterous. No matter how you slice it, you live in a demonstrably absurd existence, which is to say, a universe that intrinsically does not make sense. Story 5. To our knowledge, gamma-ray bursts, at least the longer and more dangerous ones, are caused by supermassive supernova. When a supermassive star goes supernova, 99% of the energy is radiated away through neutrinos. Yes, really, 99%. The mechanism is not fully understood, but that does seem to be the scientific consensus. Consequently, these neutrinos are extremely energetic, 10 to 20 MeV, which translates to a gamma factor of 47 to 94, and they travel up to 99.995% the speed of light. Now, of course, 99.995% is still not as fast as light, but even interstellar space, especially inside galaxies, which is where a burst would be most dangerous, is not empty. It's filled with relatively large amounts of gas and dust. This means that the effective refractive index of the interstellar medium is not 1, but a bit higher, so even light does not travel at c. Since neutrinos are weakly interacting, they basically do not care at all about this interstellar gas and dust and zoom right through. So, effectively, neutrinos may travel through interstellar space at a speed a tiny bit faster than light does, and we can detect this sudden burst of neutrinos here on Earth a while. I think it's usually hours at most before the actual gamma ray hits. Story 6. How physically hostile anything other than the Earth is. In zero-G outer space, in a spaceship, you lose bone mass to the point that you have osteoporosis, and you have all sorts of long-term organ and vision problems. You also experience radiation exposure. If the capsule leaks, you get promoted to actual outer space. On the moon, in a capsule, you have all the problems of zero-G space, except you have gravity. There are almost no usable resources. In outer space, you will experience death within a couple of minutes. On Mars, in a capsule, you are in a buried bunker to avoid radiation. Everything in the bunker is metered to control power, water, and oxygen usage. There are almost no usable resources on the surface, so everything has to be imported. If the capsule leaks, you get promoted to on the surface of Mars. On the surface of Mars, you will pass away within minutes from asphyxiation, freezing, or high radiation. All the other planets in the solar system are less hospitable than the Moon or Mars. Story 7. There are things like gamma ray bursts that would, without warning, instantly vaporize whatever side of the Earth was facing it and destroy the atmosphere, ionosphere, magnetosphere, and ending off the other side. Even worse is the possibility of vacuum decay. From my understanding, it's basically a switch where a particle says, I actually wasn't at the lowest level of energy, but now I am. Like pulling a single card from the bottom of a giant house of cards, everything comes tumbling down in a wave. At the speed of light, everything, down to atoms, is rewritten and destroyed. Even the laws of physics, nothing survives. There's no way to predict it, no way to see it coming at you, just one day, boop, gone. Story 8. This is less about space and more about space travel, but it's something I think about almost daily. Several years ago, I visited NASA HQ in Houston. We took a little tram tour, and a lot of it was about the preparation for the Mars expedition. One of the things they mentioned was that getting people to Mars wasn't the challenge per se. They had the mathematics and mechanics worked out. The main issue they were theorizing about was the potential impact on the human body. Humans who spend extended time at the space station, for instance, come back with not just deteriorated muscle mass, which is obvious because of the lack of gravity, but also a severe depreciation of their mental state. Apparently, extended time in space can impact cognitive function to the point where astronauts, upon their return, can't even complete a simple puzzle. I started to realize that while I always thought of astronauts as scientists, in reality, they're more like modern-day pioneers putting their bodies through insane tasks in search of deep space. Story 9. Humanity doesn't even rank as a Type 1 civilization on the Kardashev scale. That's not all that interesting by itself, but when you consider how much energy the sun is radiating across basically the entire electromagnetic spectrum, I believe the estimates are that we'd need to be somewhere between a Type 1 and Type 2 in order to produce a signal loud enough on our own to be distinguishable from the background noise of the sun at any appreciable distance from us. This is why in the three-body problem, Ye Wen-ji is able to contact the trisolarans by using the sun as an antenna. I don't know how valid that idea is scientifically, but it's kind of neat as a concept. So while there are plenty of reasons for wanting to abide by Fermi's paradox and the dark forest theory, the reality is that we're still essentially amoebas to anything examining us from a distance. We couldn't make enough noise to be noticed even if we tried. Story 10. When you get a glimpse of the realization of the size of the universe and the tininess of us, human beings, you will find that religion makes no sense. Why would there be a divine being that creates this huge, huge universe with billions of galaxies? And why would it create on the outskirts of one of these galaxies next to a mediocre star this tiny planet with teeny tiny living beings? And then tell these beings, when you do not do what I want you to do, you go to hell. Like, what? None of that really makes sense, and that, my friends, is how I lost my faith thanks to the deep field photos. Story 11. Using very conservative estimates in the Drake equation still suggests that there are other intelligent civilizations in the Milky Way. However, unless a civilization was our galactic neighbor, they wouldn't pick up our random radio waves. I believe you have to aim your signal right at them, so while we may share our Milky Way, we almost certainly do not make contact, which may be a good thing. Even if we do make contact, anything more than 25 light years away would mean few people would get a response to their message during their own lifetime. Also, the Drake equation calculates how long an intelligent civilization will live from their invention of radio to when they pass away, which could be a very short period of time given that we use atomic weapons about 50 years after the radio. Story 12. Most of our current understanding of the universe is just educated guesswork since all our understanding is from a sample size of one inhabited planet in a single solar system. For all we know, the universal periodic table could extend to thousands of different elements on top of the ones we already know. Also, we aren't 100% sure we know how life forms on other worlds, and for all we know, that world we deemed uninhabitable could be crawling with life forms adapted to that environment. Story 13. For starters, space is only about 100 kilometers away, and the breathable atmosphere that keeps us alive stops much earlier than that. In fact, the part of the atmosphere we can actually live in, about 8 kilometers, is about as thin compared to the size of the Earth as the skin of an apple, and that's it. Anywhere else that we know of in space will end you within minutes. The other thing is the implication of the Big Bang Theory, that space is ever expanding and will slowly cool down and darken until it is completely dark and at absolute zero forever. I personally think there is something cyclical or self-referencing going on in the universe or multiverse, but there is the distinct possibility that this isn't the case and our universe is the only one ever to exist and it will just peter out. Story 14. People born deaf who gain their hearing later in life say they expected the sun to make noise, and it does, a lot of noise, but we don't hear it thanks to the vacuum of space. If the vacuum of space didn't block sound from reaching us, the sun would be as loud as a jackhammer everywhere on Earth, everywhere at all times. And since sound travels slower than light, if the sun were to go out, it would take 8 minutes for the light to stop, but 13 years for the sound to stop. Imagine living on a cold passing Earth for 13 years and still hearing the jackhammer scream of our passing star. Story 15. On the cosmic scale, the speed of light, our theoretical speed limit, is ridiculously slow. Even with an advanced ship that could take everything we needed for the perpetuation of our species, it would take generations to reach the nearest star. If we invented perfect matter-antimatter engines and could accelerate at 1g to the halfway point, then decelerate at 1g to Alpha Centauri, it gets interesting. At the halfway point, we'd be going almost 95% of the speed of light. To the astronauts, the one-way trip would take 3.6 years. However, 6 years would pass on Earth because of relativistic effects. Also, we need to take about 36 kilograms of mass to use as fuel for every kilogram of payload. Story 16. That beyond our solar system, the distances are enormous. The distance from the Sun to Earth is about 150 million kilometers, or about 8 light minutes. It takes light 8 minutes to travel from the Sun to the Earth. The distance from Earth to the next closest star, Proxima Centauri, is 4.25 light years. Light takes 4.25 years to travel from Earth to Proxima Centauri. If we set the distance from the Sun to the Earth at 1 meter, the distance from the Earth to Proxima Centauri would be about 269 kilometers. It's really far. This means that it might well be that people can never leave our solar system because we might never be able to develop a means of propulsion that can get us that far. Story 17. I didn't realize how few people knew that we are actually moving. Our solar system is hurtling through space just like everything else. I'll never understand why so many people seem to understand that things are expanding and everything is moving, but their brains seem to stop when it comes to the idea that we are also moving and not just rotating around each other. This poses an issue with early basic time travel theories because you have to take that into consideration. Sure, you could go back in time, but if you were to just teleport into your exact spot in 1683, you'd be in empty space because the whole planet is now somewhere else. This gave my brother nightmares, but he hates space in general. Story 18. It may not actually be a true vacuum, which comes back loaded with the realization that regions of space could theoretically collapse into a true vacuum, which would be a cosmic catastrophe if you happen to be made of matter. This is not an absolute fact, it's a theoretical idea with a lot to prove, but neither is it pseudoscience. If you're curious about it, you can look up the term false vacuum decay. It's a fun concept to read about, even taking it merely as a hypothetical. Story 19. There are a lot of black holes, some of them are absolutely massive, and these are fundamentally terrifying. Also, there's a lot of chaos out there. Something heavy could drift through our solar system. Imagine a Jupiter-like mass instead of an interstellar asteroid that would destabilize our planetary orbits. Earth could be knocked into a highly eccentric orbit, or it could be arbitrarily flung all the way out of the solar system. We are in a quiet backwater of the cosmos. I think the Great Filter is just chaos itself. I expect too much radiation and shrapnel in denser regions. Story 20. How far away everything is. We humans have only managed to get to places in our own solar system. Getting anywhere else, at least with a still working spacecraft, is far beyond our capabilities. As far as manned flight goes, the furthest we've ever achieved is the moon, but we can probably get to Mars and Venus in a few years. The other issue is if something goes wrong with the astronauts, they are utterly screwed. By the time we figure out a rescue mission, they'll be long gone. Apollo 13 survived thanks mostly to some incredible luck. They just happen to have a spare ship tethered to them that could be retrofitted to keep them alive, but only just. Had the accident happened after the moon landing, they would be gone. Story 21. Regarding things people don't understand about space, probably foremost among them is how hard it is to survive there and how difficult it is to get anywhere. I find all stories about people fighting in a spaceship to be preposterous, since cooperation is necessary for survival. Think of it like a submarine, but you can't even surface for air. People who fundamentally hate each other would not survive for long on a spaceship. And then there's trying to get anywhere. The speed of light, the fastest speed allowed by our understanding of physics, is pathetically slow. It's a cosmic joke. 8 minutes to get to the sun and 4.25 years to the nearest planetary system? You gotta be kidding. Story 22. Solar weather poses a serious radiation hazard to astronauts. Solar flares are sudden releases of electromagnetic energy from the sun's surface. Coronal mass ejections send billions of tons of plasma into space. Solar energetic particle events accelerate protons to extremely high speeds. The primary danger is high-energy particles penetrating spacecraft and humans. Acute exposure causes radiation sickness, while chronic exposure increases cancer risk and damage to the central nervous system. The radiation causes cataracts and affects the cardiovascular system. During major solar events, radiation levels spike to lethal doses within hours. The 1972 solar storm, which occurred between the Apollo 16 and 17 missions, would have been fatal to astronauts on the lunar surface or in transit. The radiation can cause single-event upsets in computer memory and processors, potentially affecting navigation, life support, or other critical systems. Story 23. Alien visitation would likely be terrible for humanity. Throughout human history, whenever two cultures come into contact, the one that is less technologically advanced gets screwed. This is with a relatively small technological disparity. If an alien species is able to travel here, it means the technological disparity would be massive. So massive that it's highly likely such a species would not recognize us as anything of value. I'm not saying they would necessarily be hostile, but they would probably be indifferent to our survival. We may pat ourselves on the back for being the dominant life form on the planet, but to an interstellar alien species, we'd just be the smartest kind of mold on a generally moldy rock. Let's hope these aliens develop differently than humans. Story 24. We will never travel to another star as ourselves in the same sense as traveling to another city. This is the case with any current or future imagined technology. Even if there is technology that enables us to travel at the speed of light, it will take over 4 years to get to the nearest star. The sad truth is that thousands of years will have passed on Earth, so if we come back, even if we only felt over 4 years had passed or it felt instant, according to some theories, it won't matter that we did not feel that time while we traveled. It will matter when we get back because time will have passed where we care about it, so we must forget about dreaming of traveling as our normal selves. On the other hand, we must care about spreading the universe with our genetics and our intelligence in the form of AI. So we need to create thousands of space capsules with all of Earth's genome and AI that will cultivate it and raise it if a proper planet is found, then send these capsules in every direction in the universe and some of them will survive. A small number may find a planet that may be seeded, and that is the only way that will have the highest probability of space travel. By the way, I also believe that if there is life out there, I don't care what their biology is like, I don't think they will be here in their original shape. Most likely, it will be their robots or tech that is mixed with their genetics, but not in their original shape. Story 25. Let's talk about Phoenix A. It is the largest black hole ever discovered. Its predecessor for the largest was Ton 618. That black hole's discovery led to a new definition of black holes, ultramassive. So just how big is Phoenix A? It has the mass of 100 billion solar masses, with a Schwarzschild diameter of 367 billion miles or 590.5 billion kilometers. Now, the problem with really big numbers like this is that it's hard to have perspective on them. We just can't imagine things that big, but it helps us scale things down and compare sizes to something more earthly. So I ran the numbers. Scaling down our solar system, I started by setting the sun to 3 feet or 0.9 meters in diameter. The Earth, scaled down by the same percentage, would be about the size of a tiny ball bearing. Scaled down by the same percentage, Phoenix A would have a diameter of approximately 240 miles or 386 kilometers. That is roughly the distance between Boston, MA and Philadelphia, PA. And if you're enjoying the video too, don't forget to hit that subscribe and like button for more videos just like this. Story 26. The Great Attractor, which lies about 147 million light-years away, is a mysterious mass that is pulling on everything within about a 500 million light-year distance. What it is, we don't know, but we do know its mass is around 10 quadrillion times more than our sun. That is hundreds of thousands of times more than the largest ever discovered black hole or even the most massive galaxy. It is also obscured by the Milky Way galaxy lying directly in the path of the galactic core. As such, we have no way to see it directly. We would have to go to the far edge of the galaxy to do so, maybe even further. Story 27. Want to know the reason we haven't been back to the moon in 50 years? First, there isn't much to do there and it's really expensive. But another reason is due to the solar flares in 1972. In 1972, between the Apollo 16 and Apollo 17 missions, there was a massive solar flare that would have ended the cruise if they were in space at the time. There isn't really anything you can do in space about the radiation, and it's kind of hard to predict when it's going to happen, so you just kind of have to hope for the best. In the end, a major factor in why interplanetary travel hasn't become more feasible is due to this radiation. Story 28. In a few billion years, if the expansion of the universe keeps on exceeding the current theory, any new civilizations born then will think their galaxy is all they have. This is because the universe will be expanding far beyond the speed of light, so light from distant galaxies will never reach them. Today, we know of the billions of galaxies out there, and we should feel privileged that the space we see today in the sky allows us some magnificent views. Future civilizations won't have that privilege. Heck, they won't even know about it, which is sad. Story 29. No matter how cool you think it is, no matter how much you want to go, no matter how long or how hard you train to be an astronaut, no matter how much being in space is your dream, you may still have a massive panic attack once you cross out of the Earth's atmosphere and hate your time in orbit. Many astronauts experience an overwhelming sense of grief and dread upon looking at actual outer space from a shuttle window. This phenomenon actually ruined the trip to space for William Shatner, who had wanted to go to space for decades. Story 30. It's expanding in every direction, all at once, at large scales, and that compounds with distance, meaning very distant objects are moving away from us faster than the speed of light. This means anything over a certain distance, the quote-unquote observable universe, we will never be able to observe. But it's more than just about light, it's about causality. Since light speed is actually the fastest speed at which information can be communicated, two objects moving apart faster than light might as well not exist to one another. There's no way we could ever interact with or affect the other. Now, let's get even scarier. This rate of universal expansion is actually increasing. Over very long timescales, the sky will become darker and more sparse as extragalactic objects move beyond the boundary of the observable universe relative to us. Compounded with the end of star formation in our own galaxy, the existing ones will burn themselves out until there is absolutely nothing left in the night sky. It will be totally and completely black. Well, to clarify, humans, the Earth, and the Sun will be long gone by then, so there will be no one left to observe this. Eventually, the entire universe's space will be so stretched out and matter so degenerate that any particle in it cannot possibly interact with any other particle in it, and thus things just stop happening. No more history of anything, no particle interactions, just isolated particles chilling at their lowest energy state, unable to get within range of another to accomplish anything. Time will cease to have meaning because absolutely nothing can happen. Now that's beautiful and utterly terrifying. Story 31. So perhaps you've seen movies where a spaceship is in space in like intergalactic space, like The End of the Empire Strikes Back, where they look out upon a galaxy from without. Well, look up into the night sky and find Andromeda. It's there, but it's pretty darn faint. Now everything else you see is stars, the moons, or planets, maybe a shooting star. All those things are in the Milky Way, so if you were in intergalactic space, say halfway between the Milky Way and Andromeda, think about what it would look like. Andromeda would be 4 times as big and bright, which would still be quite faint indeed. And everything else in the sky, as it's part of the Milky Way, would be just as far away and cumulatively about as dim as Andromeda is. That is, it would only be marginally more lit than if you were in a closet with the lights off and the lights off in the room outside. One Chinese keychain LED light from the 90s with your thumb covering it would be 1 trillion times brighter. It would be almost pitch black in every direction. If there were another ship 300 meters off the bow, unless it had marker lights or your ship was shining a spotlight on it, there wouldn't be enough ambient light to see it. Wave your hand in front of your open eyes in the closet, that's what it would look like. Just darkness in every direction. All these pictures of galaxies you've seen are either paintings or long exposures. To the eye, it's just blackness. Story 32. When we conceptualize space, we typically limit ourselves and think laterally in the way we think of wide open spaces and directions on Earth. We extend this thinking beyond the plane in which the Earth orbits the Sun and imagine some distant galaxy way over there, laterally, and think, wow, that's really far away. But with regard to space, that plane in our conventions of up and down are arbitrary, and the universe is vast in all directions, up and down from Earth's poles, as well as beyond the plane of Earth's orbit. So whenever you stare into the night sky, imagine the Earth as a lifeboat, and you are looking over the side of the boat and down into the depths of an ocean flecked with suspended stars and galaxies. And you thought the Pacific Ocean was deep. Story 33. I don't know about terrifying, but Prof. Brian Cox did a very good job of breaking down just how unlikely it is that we will ever meet alien races, which boils down to how unlikely it is a civilization like ours can evolve to the point we are at, being able to calculate our place in the universe and understand it. All multicellular life on Earth evolved from one single encounter between 2 single-celled life forms, where one absorbed the other, but instead of being digested, they formed a symbiotic relationship with the inner cell releasing energy that meant the outer cell could freely evolve. The inner cell is now our mitochondria. There was single-celled life on Earth for 4 billion years before this one-chance meeting of two cells, called the fateful encounter hypothesis, and all multicellular life forms are descended from it, whether it's grass, elk, or toadstools. There are likely billions of planets that can and do support cellular life in the universe, but this fateful encounter seems to show that multicellular life like ours is vanishingly rare. And in the conditions needed to allow life to evolve to our point of civilization, the right electromagnetic field, having a tidal moon, having a gas giant like Jupiter to draw away dangerous asteroid strikes, etc. Basically, it boils down to no, we aren't going to be visited by aliens because the likelihood of another civilization evolving from vanishingly unlikely natural odds than being in the same cosmic time window as us, let alone within visiting distance, is as close to zero as probability allows. Story 34. I see a lot of people confused about light speed travel around here, so here's a quick lesson. If you travel at the speed of light, you'll reach your destination instantly, regardless of distance. It will not be the same for me as an observer, though. For example, imagine it's 2028, middle of the night, and you just got 25 years old. You are working for NASA on an experimental ship testing light speed travel. Your wife calls you with your newborn in her arms, wishing you a happy birthday and telling you that they await your return at home and they will miss you the next 4 months. You end the call, then get back at the ship controls, input a destination that's 2 light speed months away, and press the big red button. Before even releasing the button, you're already there. Then something dawns on you. Everything seems unfamiliar. You panic, select the last destination, and press the red button again. And as the last time, you're back at your initial point instantly. You try to contact your base and you get confused and panic responses. You are hurried to land, and after you do, you realize there's a big commotion and you don't understand why. Then you see it's a calendar. It's the year 2068. Instead of traveling 2 months, you traveled 20 light years. 20 going to, 20 going back in case someone is confused, so 40 years in total. Then you meet your son, who was a toddler a few months ago but now is 40 years old. You are still 25. Your wife is 65 years old. You look at these two strangers and your mind starts to break. The woman you love does not exist anymore. The toddler you held in your arms when he was born does not exist anymore. They are alive and in front of you, but your mind can't accept it. And I'll stop here because I'm getting swayed by my writing hobby. So to answer the question, the fact that we're never going to see the space in real time, the moon is 1 second in the past, the sun is 8 minutes in the past, and as the distance increases, so does the delay in real time. If there is an alien civilization 66 million light speed years away who could point a telescope at our planet and see it clearly, they will just start to see the extinction of the dinosaurs. Story 35. It is a common misconception that astronauts in orbit are weightless because they have flown high enough above the atmosphere to escape the Earth's gravity. In fact, at an altitude of 400 kilometers, 250 miles, equivalent to a typical orbit of the ISS, gravity is still nearly 90% as strong as at the Earth's surface. Anything at that height not orbiting would plummet back down to Earth. Weightlessness actually occurs because orbiting objects are in freefall. If you imagine a cannonball shooting out of a cannon, you will see its trajectory form an arc. The faster that cannonball gets shot out, the larger that arc becomes. So, if the cannonball was to be shot out fast enough, its curving arc would match the curvature of the Earth, and that is what we call orbiting. Fortunately, at the height of the ISS and Space Shuttle, there is no atmosphere to slow that orbit down, so it's a good height to keep them up there. Story 36. You're a million miles away from, well, anything really. Think about Apollo 13. It was going to the moon, which is the closest thing in space you can get to that isn't a space station. Had they not had Aquarius to use as a lifeboat, they would have been gone. We simply did not have the time or the resources to get to them in time. Now imagine they were going to Mars. The idea of being lost in space is good science fiction fodder. In reality, you're almost 100% likely to pass away long before any rescue can even be launched. Story 37. We may have already missed the window to understand how the universe works. For example, most of our understanding of the universe comes not from seeing the stars, but from seeing other galaxies. We can understand the size of the visible universe from this. We can measure the rate of expansion of the universe from the redshift present in the farthest galaxies. We can see supernovae in other galaxies that help us calibrate our tools. Basically, everything we know about the universe comes from being able to see other galaxies. Eventually, the rate of expansion in the universe will be fast enough and the galaxies will be so far apart that their light will no longer be capable of reaching us, and most of the lights in the sky will wink out, never to be seen again. Any life or culture that evolves after that point will never know other galaxies exist. The galaxy they are in will be the limit of creation because it will be all that they can ever see, no matter how hard they try or how advanced their technology gets. Their window for understanding the universe will have closed. And it's entirely possible such a window for understanding the true nature of the universe has already closed for us. Something, and we have no way of knowing what, may have already passed the point of no return, and we will never, ever understand the universe because of it. No matter how good our technology gets, no matter how smart we become, it may simply already be too late. Story 38. As in, the space beyond our atmosphere, it's saturated with dangerous radiation, there's nothing to breathe, and there's no pressure to keep you from blowing up like a balloon. As far as we know, the vast majority of the universe is wildly hostile to life. A single gamma ray burst or a nearby supernova could scour our planet clean. The fact that we're here is a giant lottery win that could be over at any minute. We're all alone here and sitting in a firing range. Once you truly appreciate this, you'll never feel so small. Story 39. It's not still. Things are not just floating there in space. Everything is moving around at astounding speeds. And it's all leaving a wake behind it too, of debris and weird solar winds and maybe other disturbances that we barely know anything about. So space is more like the open ocean, but nothing is anchored to anything. Everything is always moving around, creating huge wakes behind them. Our entire solar system moves as a unit while rotating around our sun at the same time. So imagine traveling to another solar system. We first have to leave this hurling ball of planets, fire, and rocks, and then try and hit another equally hurling ball of planets, fire, and rocks. Story 40. This may either be terrifying or comforting, but nonetheless, everyone hears about how old the universe is, 13.7 billion years, but no one ever talks about how old it's projected to become. The predicted ages of the universe are divided into 5 different periods: the primordial era, Big Bang and stuff, the stelliferous era, stars and galaxies and stuff, the degenerate era, when that stuff starts to break down, the black hole era, self-explanatory, lots of stuff reduced to black holes, and finally the dark era, when everything kind of decays, gets inactive, and turns into a void. As you may have guessed, we're currently in the stelliferous era, so how long will this last? Maybe a few more billion years? 5 billion? 10 billion? 20? Nope, top estimates say 100 trillion years. So, using this estimate, if the entirety of the stelliferous era were a year long, we'd be barely an hour in, including the brief primordial era beforehand, 100,000 years. And this doesn't even account for the absurdly long eras to follow. Long story short, yes, the universe is insanely old and that's scary, but how old it's going to be messes with your mind even more. Story 41. If you and your friend were floating through space and you came across a supermassive black hole and one of you got pulled in while the other remained at a safe distance and watched, something interesting would happen. The person who got pulled into the black hole would travel towards the middle, and since it is supermassive, they would not be spaghettified as they crossed into the deeper parts of the black hole. However, since time distortion is so great while in a black hole, the theory is that the person falling in would have time slow down so severely that there would be no point in time where they could burn up and pass away while crossing the event horizon. This is different for the person watching from a safe distance, though, who would witness their friend burn up at the event horizon and pass away. This effectively causes a distortion of reality where the viewer sees the victim pass away, but the quote-unquote victim does not ever pass away from their point of view, creating 2 separate realities in the same universe and breaking the laws of physics. Story 42. In billions and trillions of years, basically far into the future, the basic laws of entropy will cause matter itself to break down. Planets, stars, and galaxies will not exist, civilizations will not exist, and the universe will be a cold, dark, and uneventful place. However, because we are dealing with vast timelines, very low probability events become realistic. There exists the possibility of random atoms coming together to form your brain. Statistically speaking, it is actually far more likely that your life, as you know it, isn't a corporeal existence in our current visible matter universe, but rather this ephemeral formation of your brain with all your current memories, personalities, and emotions in a very old universe. And just as it appears, it disappears along with your existence. Story 43. I don't know if this is exactly related to space, but time, yes. Imagine you are finally able to build a machine that can travel faster than light. If you travel faster than light, it will permit you backward time travel. Imagine when you start, you pin your location to come back. You start your journey of 13.7 billion light years to be covered in a quarter of a human lifetime. You will be able to witness the creation of the universe, and when you come back to the point you started, you will cease to exist because you traveled back before anything else existed. There are many flaws. For example, the energy required and the mass of an object that can go at the speed of light will be infinite. There may be a lot of them in this comment, and what happened was that I was reading all the comments and Neil deGrasse Tyson talked about traveling to the farthest points of space to collect more data about creation. It struck me, so I thought I'd just jot it down. Story 44. Not space specifically, but more related to the fabric of our universe. The Planck length, what scientists have determined to be the shortest measurable length anything can be, is so small there are more Planck length units in 1 millimeter than there are stars in all the galaxies of the universe. A Planck second, the shortest measurable unit of time, is so short there are more Planck seconds in 1 second than seconds that have elapsed since the Big Bang, some 13-14 billion years. As for space itself, there's the old standard. There are more stars in the universe than there are grains of sand on all the beaches of the entire world. Story 45. What's scary about space is what a hostile environment it is. Obviously, I knew that as a concept because it was my job. I worked in the space industry, but it really got through to me one day when I was looking through a porthole into the test chamber at IABG in Ottobrunn, Germany during a thermal balance test of a satellite I had been involved in. The chamber was a pump vacuum, the walls were cooled with liquid nitrogen, and a solar simulator was radiating merciless light at 1300 watts metered square onto the spacecraft. I noticed that the shadows from various bits sticking out of the spacecraft were razor sharp. There was none of the blurring at the edges that you see with shadows here on Earth. They're caused by the ambient air, but in space, there is no air, no blurring. The walls, we call them shrouds, were at 75 K, which is about minus 200 degrees Celsius or minus 320 degrees Fahrenheit. Space, really is hostile. Story 46. Cosmic ray visual phenomena. My own explanation follows. Sorry if I missed something. Your eyes have tiny light detectors which can be triggered even when your eyes are closed. That can occur when a receptor is being hit by a very high-energy particle like the ones that make up cosmic radiation. This does not happen on Earth as all of those particles are hitting the atoms in the atmosphere and do not make it all the way back down to Earth. The Earth's magnetosphere also blocks them, so when you are on board a spacecraft, rocket, or space station, you can experience a super bright flash of light with closed eyes. Now we understand the phenomena, but imagine the first astronauts ever. You go to space in a big frickin' rocket that can explode in the roughest ride of your life to go somewhere no one has ever been. You close your eyes to fall asleep and you randomly see bright flashes of light. I would freak out. Also, the first conversation between astronauts, all of whom experienced that, needed to be weird as heck. So dude, do you see a bright light when you close your eyes? And that relief that you did not damage your brain or something, and it's just space particles. Story 47. The universe is in a false vacuum. This means that the universe is actually stuck in a quantum valley, and eventually it will find a state closer to the ground or even a true vacuum. But in any case, due to quantum rules, eventually a piece of space-time will quantum tunnel into a lower ground state and then bring the rest of the universe with it. It will happen at the speed of light and you won't even know it happened. The entire universe will be torn apart and turn into a completely different space-time configuration. Maybe it will go down to the true ground state or vacuum, or maybe that's impossible and it's just a cyclical event that happens every trillion years or so. And if any of these stories got to you, here's more for you. YouTube thinks you're gonna love this. I'll catch you in that video.